Listen to that sound. That is not music. That is not a machine error. That is Saturn itself, screaming into the endless void of space, broadcasting a signal we were never meant to hear. For hundreds of years, we gazed upon it through primitive lenses and saw only beauty, a golden god suspended in darkness, crowned with rings of ethereal light. We called it the jewel of the solar system. We painted it on cathedral ceilings. We whispered its name in wonder. But beauty, you must understand, is nature's oldest deception. It is the lure that draws the moth into the flame. And Saturn? Saturn is not what it seems. It is not peaceful. It is not gentle. It is a violent colossus, a churning ball of hydrogen and helium spinning with such ferocious speed that it distorts its own shape, flattening itself into something grotesque, something closer to a pumpkin than a sphere. This is a world where storms rage for centuries, where geometric nightmares carve themselves into the atmosphere, where gravity is so merciless it tears entire moons to pieces just to adorn itself with their corpses. This is not a jewel. This is the Lord of Chaos, and we are only beginning to understand what that means. Let us start with what you think you know, the rings. From Earth, even through our most powerful telescopes, they appear as smooth bands of pure gold, perfectly ordered, eternal. They look like something designed by a cosmic architect, a celestial artwork hung in the gallery of space. But if you were to actually venture inside them, if you were to pilot a craft into that golden halo, you would discover the terrible truth. These rings are not solid. They are not peaceful. They are a blizzard of violence, a chaotic maelstrom of ice and rock, fragments ranging from particles smaller than grains of sand to boulders the size of mountains, all of them orbiting at thousands of kilometers per hour, constantly colliding, shattering, pulverizing each other into smaller and smaller pieces before reforming into larger chunks in an endless cycle of destruction and creation. Imagine, for a moment, that you are there. You are floating inside this storm. Around you, in every direction, millions upon millions of ice shards are screaming through space. Some are no bigger than snowflakes, catching the distant sunlight and glittering like diamonds. Others are the size of houses, dark and jagged, tumbling end over end with enough kinetic energy to obliterate anything in their path. The noise would be deafening. If sound could travel in space, an endless percussion of impacts, a symphony of shattering ice and grinding stone. This storm stretches nearly 300,000 kilometers wide, a distance that could swallow nearly 8 Earths placed side by side. And yet, despite this incomprehensible scale, the rings are impossibly thin. In some places, they are barely 10 meters thick. Think about that. A structure wider than the distance from Earth to the Moon, yet thinner than a 4-story building. It is a blade, a razor cutting through the darkness, a cosmic guillotine made of frozen water and ancient rock. But where did this violence originate? How did these rings come to be? The answer is darker than you might imagine. The answer is murder. The prevailing theory among planetary scientists is one of profound tragedy. Long ago, perhaps billions of years in the past, there existed a moon. We do not know its name. We never will. It may have been as large as Titan, Saturn's largest remaining moon. It may have had its own geology, its own mountains and valleys, perhaps even a subsurface ocean. For eons, this moon orbited Saturn in relative peace. But moons do not orbit forever in perfect stability. Over time, gravitational interactions with other moons, subtle tugs from Saturn's immense mass, and the slow decay of orbital energy drew this moon closer and closer to the planet. Eventually, it crossed a threshold, a point of no return known to physicists as the Roche limit. This is the distance at which a celestial body's own gravity can no longer hold itself together against the tidal forces exerted by the planet it orbits. Imagine being pulled apart by invisible hands, hands that grip your feet and your head and pull in opposite directions with unstoppable force. That is what happened to this moon. Saturn's gravity seized it, and then, with brutal efficiency, the planet ripped the moon's crust from its core. It shredded, a living world. if we can call any moon truly alive, into trillions upon trillions of icy fragments. The moon's water ice, its rocky core, everything that had made it a distinct body in the solar system, was torn apart and scattered into a vast disk around Saturn. The beautiful rings we admire today, the rings that poets have written about and artists have painted, are not jewelry. They are not ornaments. They are the scattered remains of a dead moon. We are staring at a planetary graveyard, a memorial to a world that no longer exists. Every particle in those rings was once part of something whole, something that had its own story, its own place in the solar system. And now it is nothing but debris, caught in an eternal orbit, slowly spiraling inward, doomed to eventually rain down onto Saturn's atmosphere and disappear forever. But the strangeness of Saturn, the true eeriness of this world, extends far beyond its rings. Look at the North Pole. Go ahead. Find an image of Saturn's northern hemisphere and look closely. What you will see defies everything we think we know about how planets should behave. Nature, you see, does not make straight lines. Fluid dynamics, the science of how gases and liquids flow, tells us that rotating systems should create circles, spirals, eddies, and vortices. Hurricanes on Earth are circular. Cyclones are circular. The Great Red Spot on Jupiter, that massive storm that has raged for centuries, is an oval. But on Saturn? On Saturn, there is a hexagon. This is not a symbol carved by some ancient civilization. This is not an optical illusion or a trick of atmospheric chemistry creating a visual pattern. This is an actual, physical, geometric shape, a six-sided storm system with nearly perfect straight edges, each side stretching approximately 13,000 kilometers. To put that in perspective, the distance from New York to Tokyo is approximately 11,000 kilometers. Each side of this hexagon is longer than that. The hexagon is wide enough to swallow 4 Earths whole, and it is not just a surface feature. The walls of this storm reach hundreds of kilometers deep into Saturn's atmosphere, churning through layers of hydrogen, helium, and trace compounds with winds that exceed 300 kilometers per hour. At the very center of the hexagon sits something even more disturbing, a massive vortex, a spinning maw of atmospheric chaos that appears red in enhanced color images. It looks, to many observers, like a rose made of hurricanes, a flower blooming in the darkness, beautiful and terrible in equal measure. This storm has been raging for decades, possibly for centuries. We simply do not know how long it has been there, because we only discovered it when the Voyager spacecraft flew past Saturn in the early 1980s. And here is what truly unsettles scientists. It is stable. Storms on Earth come and go. Hurricanes form, rage for a few days or weeks, and then dissipate. Even Jupiter's Great Red Spot, while long-lived, changes size and intensity over time. But Saturn's hexagon? It just sits there, year after year, decade after decade, a geometric scar that never heals, staring unblinkingly into the void like a giant alien eye. We still do not fully understand how it forms or why it maintains such perfect geometry. Computer models can replicate hexagonal patterns in rotating fluids under certain conditions, but the precision and stability of Saturn's hexagon remain mysterious. It is as if the planet is following mathematical rules we do not yet comprehend. Rules that govern the behavior of matter on scales so vast they dwarf anything we experience on Earth. And when Saturn gets angry, when something deep within its atmospheric engine awakens, the entire planet transforms. Every 30 Earth years, roughly equivalent to 1 Saturnian year, one complete orbit around the Sun, a monster wakes up from the depths. We call it the Great White Spot, though that name hardly does justice to its scale and fury. This is not a localized storm. This is a planetary event, a convulsive eruption that begins as a small white disturbance and then grows, spreading across the atmosphere until it wraps around the entire circumference of the planet like a festering wound. Imagine a thunderstorm. Now imagine that thunderstorm covering not just your city, not just your state or country, but the entire surface of Earth. Every continent, every ocean, every pole, consumed by a single storm system, that is, the Great White Spot. And the lightning within it? 10,000 times more powerful than the strongest lightning on our world? The electrical discharges are so intense that they can be detected from Earth, bursts of radio energy screaming across nearly 1.5 billion kilometers of space to reach our antennas. This storm churns up massive plumes of ammonia ice from deep within Saturn's interior, clouds of frozen gas that rise through hundreds of kilometers of atmosphere to reach the visible cloud tops. These white clouds spread and merge, turning the normally golden planet into something ghostly, something pale and wrong-looking. It is a reminder, if we needed one, that beneath those calm, banded clouds we observe from Earth, beneath the tranquil appearance of this distant world, there is a chaotic engine of heat and energy constantly at work. Saturn is not sleeping. It is merely waiting. And when it erupts, it does so with a violence that dwarfs anything our planet has ever experienced. But Saturn is not alone. It is the king of a massive entourage, a court of more than 140 moons, each one a world unto itself. Some are tiny, barely more than captured asteroids, irregular chunks of rock tumbling through space. Others are substantial, large enough to have their own geology, their own histories. And one of them is an imposter. A moon so strange, so unsettling in its similarity to Earth, that it forces us to reconsider what we think we know about where life might exist in the universe. Titan. The name itself sounds mythological, and for good reason. This is the only moon in the entire solar system with a thick atmosphere. When the Voyager probes first flew past Titan in the 1980s, they found a world shrouded in orange haze, completely opaque to visible light. Scientists were baffled. What was hidden beneath those clouds? It took decades, and the arrival of the Cassini spacecraft in the early 2000s to finally peer through the haze and see the surface. What they found was staggering. Titan has weather. Titan has seasons. Titan has rivers that carve channels through its landscape, lakes that dot its polar regions, and rain clouds that drift through its skies. The air pressure on Titan's surface is actually higher than on Earth, about 1.5 times Earth's sea level pressure. If you stood on Titan without a pressure suit, you would not explode or have your lungs crushed. You would simply freeze to death in seconds. But the fact remains, Titan, in many ways, looks startlingly like home. But do not be fooled. Do not let the familiar shapes, the river valleys, the lake shores, the weather patterns, trick you into thinking this is anything like Earth. Titan is a twisted, toxic reflection of our world, a nightmare version of home built from the wrong materials. The rain is not water, it is liquid methane, liquid natural gas, the same substance we burn in our stoves and furnaces, falls from the sky in a slow, dreamlike cascade, pulled down gently by Titan's low gravity. The temperature hovers around -179 degrees Celsius. At that temperature, water ice is as hard as granite. If you jumped into one of Titan's lakes, vast bodies of liquid methane and ethane, hundreds of kilometers across, you would not just freeze. Your body would become so brittle that you would shatter like glass on impact. And the ground? The beaches and dunes you see in images from the surface? That is not sand. The massive dune fields of Titan, some of them hundreds of meters high and stretching for hundreds of kilometers, are made of dark hydrocarbon grains, essentially tiny particles of plastic, formed from organic molecules broken apart by ultraviolet light from the sun and reassembled into complex carbon chains. These dunes are electrically charged, crackling with static electricity as they shift and move in Titan's alien winds. The landscape is a desert of frozen gasoline under a sky of methane rain clouds, lit by a dim orange sun filtered through layers of smog. It is a world that mimics life, but is built from the ingredients of death. And yet, scientists wonder, could there be life in Titan's methane lakes? Not life as we know it, not anything based on liquid water and carbon chemistry as we understand it, but something else, something adapted to those frigid, hydrocarbon seas? It seems almost impossible, and yet, Titan reminds us that the universe is full of possibilities we have not yet imagined. Further out from Saturn, in the icy reaches of its moon system, lies a tiny, bright ball of pure white ice, Enceladus. For years, scientists thought it was just another frozen rock, one of dozens of icy moons that populate the outer solar system. It was small, barely 500 kilometers in diameter, and bitterly cold. There was no reason to suspect it was anything special. But then, when Cassini arrived and began taking high-resolution images, scientists noticed something strange. At Enceladus' south pole, there were long parallel fractures in the ice, dark blue scars, cutting across the otherwise pristine white surface. They called them tiger stripes. And from these scars, Enceladus bleeds. Giant geysers of water vapor erupt from the fractures, shooting hundreds of kilometers into space at supersonic speeds. Cassini flew through these plumes, analyzing their composition with its onboard instruments, and what it found was astonishing. This was not just water vapor. It contained salt, organic molecules, and traces of silica minerals that typically form in hot water, interacting with rock. The only explanation that made sense was this. Beneath Enceladus's frozen shell, hidden under kilometers of solid ice, there exists a global ocean of liquid water. But how could such a small moon maintain liquid water? It should be frozen solid, a lifeless ice ball devoid of any internal heat. The answer lies in Saturn itself. The planet's immense gravity pulls on Enceladus as the moon orbits, and because Enceladus's orbit is slightly elliptical, the strength of that gravitational pull varies. This creates tidal forces that flex and squeeze the moon like a ball of dough being kneaded by invisible hands. That flexing generates heat through friction, enough heat to keep Enceladus's core warm and maintain a liquid ocean beneath the ice. This ocean has salt, it has heat, it has organic molecules, the building blocks of life as we know it. In the deep, dark, high-pressure environment beneath Enceladus's ice shell, shielded from the harsh radiation and vacuum of space, something might be swimming. We do not know. We have no way to know without sending a probe to drill through the ice and sample the ocean directly. But the possibility is there, tantalizing and profound. We went to Saturn looking for gas and rock and gravitational dynamics. We might leave having discovered neighbors. But to learn these secrets, to uncover the mysteries hidden in Saturn's rings and moons and storms, we had to make sacrifices. In 2017, the Cassini spacecraft, our lone emissary at Saturn for 13 years, finally ran out of fuel. It had been an extraordinary mission, rewriting textbooks and revealing wonders no one had anticipated. But with its fuel depleted, Cassini could no longer maintain its orbit. Left to drift, it might have eventually crashed into one of Saturn's moons. Perhaps Enceladus, with its pristine subsurface ocean, or Titan, with its lakes and organic chemistry. The risk of contaminating these worlds with Earth microbes clinging to the spacecraft was too great. So NASA made a decision. They ordered Cassini to commit suicide. On its final orbit, Cassini dove straight into the atmosphere of the planet it had studied for more than a decade. As it plunged toward Saturn's cloud tops, the spacecraft fought to keep its antenna pointed at Earth, transmitting data until the very last moment, sending home one final stream of measurements and observations, a death song carried across the void. But Saturn showed no mercy. The heat and pressure of atmospheric entry tore the robot apart. Its instruments failed one by one. Its structure buckled and melted. And then, in a final blaze of incandescence, Cassini vaporized, its atoms mixing with Saturn's atmosphere, becoming part of the planet forever. A fitting end, perhaps, for a machine that had devoted its existence to understanding this alien world. Saturn feels eternal. When we look at it through a telescope, when we see those rings glowing in the darkness, it seems like something that has always been and always will be. But it is not. Even the rings, those magnificent structures that define our image of the planet, are dying. Gravity is slowly pulling the ring material down into Saturn's atmosphere, in a process scientists call ring rain. Particles in the rings lose energy through collisions and interactions with Saturn's magnetic field, and as they lose energy, they spiral inward. Every second, thousands of kilograms of ring material fall into the planet, evaporating in the upper atmosphere like meteors burning up in Earth's sky. At the current rate of decay, scientists estimate that in approximately 100 million years, a blink of an eye in cosmic time, less than the time it took for dinosaurs to evolve and go extinct on Earth, the rings will be gone. Saturn will be just another lonely gas giant in the darkness, stripped of its crown, indistinguishable at a casual glance from Jupiter or Neptune. The most iconic feature of our solar system, The image that has graced countless book covers and inspired generations of astronomers is temporary. We are living in a brief window of cosmic history when Saturn has rings. Our ancestors 100,000 years ago saw them, though they did not know what they were seeing. Our descendants 100 million years from now, if humanity still exists, will look at Saturn and see only a sphere. This impermanence should humble us. It reminds us that nothing in the universe is permanent, that even the most massive structures, the most seemingly eternal features of our cosmic neighborhood, are subject to change and decay. The rings of Saturn are not eternal jewelry gifted by the gods. They are debris, temporary and doomed, slowly but inevitably returning to the planet that destroyed the moon from which they came. So, look at Saturn while you can. Take the time to point a telescope at the southern sky on a clear night and find that golden point of light among the stars. Even a modest backyard telescope will show you the rings, that impossible halo of light encircling the planet. Know that you are seeing something that will not last forever. You are witnessing a temporary masterpiece of gravity and violence, a beautiful trap that lured us across billions of kilometers of space, only to show us how small we really are, how brief our existence is against the timescales of planetary evolution. But let us return to the planet itself, because we have only begun to explore its strangeness beneath those cloud bands, beneath the storms and the hexagon and the great white spots. What actually exists? What is Saturn made of? The answer is both simple and deeply strange. Saturn is composed primarily of hydrogen and helium, the two lightest elements in the universe, the building blocks left over from the Big Bang. In fact, Saturn is the least dense planet in the solar system. If you could find an ocean large enough, and you would need an ocean larger than anything that exists, Saturn would float. A ball of gas so massive it contains 95 Earths worth of material, yet so diffuse it would bob on the surface of water like a beach ball. But to call Saturn a ball of gas is misleading, because as you descend into its atmosphere, the conditions become increasingly extreme. At the cloud tops, where Cassini made its final measurements, the temperature is a frigid minus 140 degrees Celsius. The atmosphere is thin enough that you could, in theory, fly a spacecraft through it, though the winds would buffet you at hundreds of kilometers per hour. But as you descend deeper, the pressure increases. The hydrogen around you grows denser. The temperature rises. 100 kilometers down, 200, 500, the atmosphere becomes so thick that the distinction between gas and liquid begins to blur. Eventually, perhaps several thousand kilometers below the cloud tops, the pressure becomes so immense that hydrogen undergoes a phase transition. It becomes a liquid, but not liquid hydrogen, as we might imagine it in a cryogenic tank. This is something far stranger. At the depths of Saturn, the pressure is millions of times greater than Earth's atmospheric pressure. Under those conditions, hydrogen atoms are crushed together so tightly that their electrons are stripped away, creating a substance called metallic hydrogen, a liquid metal made of the simplest element in the universe. This metallic hydrogen ocean conducts electricity, and as it churns and flows in Saturn's interior, driven by the planet's rapid rotation and internal heat, it generates an enormous magnetic field that extends millions of kilometers into space. And at the very center of Saturn, we do not know for certain. There may be a core, a solid or partially solid mass of rock and metal, perhaps 10 to 20 times the mass of Earth, compressed to unimaginable densities by the weight of the entire planet pressing down on it. Or there may not be a distinct core at all, just a gradual transition from metallic hydrogen to a denser mixture of heavier elements. We have theories, models, based on observations of Saturn's gravitational field and its rate of rotation, but we cannot know with certainty. We have never been to the center of a gas giant. We never will. The pressures and temperatures would vaporize any probe we could conceive of long before it reached the core. What we do know is that Saturn radiates more heat than it receives from the Sunday. Unlike Earth, which is warmed almost entirely by solar radiation, Saturn has an internal heat source. Deep within the planet, helium droplets rain down through the metallic hydrogen ocean, releasing gravitational potential energy that converts to heat. This process, combined with the residual heat from Saturn's formation 4.5 billion years ago, means that Saturn is still cooling, still slowly contracting, still releasing the energy it captured when the solar system was born. It is a dying ember from the furnace of planetary formation, and it will take trillions of years to fully cool. This internal heat drives Saturn's weather, powers its storms, and creates the complex atmospheric dynamics we observe. The bands of clouds we see, those horizontal stripes of gold and white and brown, are created by rising and sinking columns of gas, convection cells driven by heat from below and shaped by Saturn's rapid rotation. The planet spins once every 10.5 hours, a day shorter than half an Earth day. This rapid rotation creates tremendous Coriolis forces, shaping the atmospheric flow into those distinctive bands and contributing to the formation of storms like the hexagon and the Great White Spot. But there is another phenomenon at Saturn that reveals just how alien this world truly is: the magnetosphere. Every planet with a liquid, conducting interior Earth, Jupiter, Saturn, generates a magnetic field. Earth's magnetic field protects us from solar radiation, creating the beautiful auroras at our poles and shielding our atmosphere from being stripped away by the solar wind. Saturn's magnetic field is similar in function, but utterly different in scale. It extends millions of kilometers into space, creating a vast bubble called the magnetosphere that encompasses not only the planet itself, but its entire ring system and many of its moons. Charged particles from the sun, the solar wind, interact with this magnetosphere, creating radiation belts similar to Earth's Van Allen belts, but far more intense. These radiation belts can damage spacecraft electronics and would be lethal to any unprotected human foolish enough to venture into them. But they also create auroras at Saturn's poles, shimmering curtains of light that dance in the upper atmosphere. Unlike Earth's auroras, which are primarily green and red from oxygen and nitrogen, Saturn's auroras are primarily ultraviolet, invisible to human eyes, but spectacular in images captured by space telescopes. And here is where it gets truly strange. The moons interact with the magnetosphere. Enceladus, with its water geysers, pumps thousands of tons of water vapor into space every day. This water gets ionized by ultraviolet light from the sun and by interactions with Saturn's magnetic field, creating a torus, a donut-shaped cloud of charged particles that orbits Saturn in the same path as Enceladus. This torus feeds particles into Saturn's magnetosphere, creating a complex ecosystem of plasma and radiation that connects the moon to the planet. Titan, too, interacts with the magnetosphere, but in a different way. Titan's thick atmosphere extends hundreds of kilometers above its surface, and as the moon orbits through Saturn's magnetosphere, the charged particles in the magnetosphere slam into Titan's upper atmosphere, stripping away molecules and creating a trail of atmospheric material that stretches around Saturn's orbit. Titan is slowly losing its atmosphere to space, bleeding gas into the void. It will take billions of years, but eventually, Titan's atmosphere will be gone, stripped away by the relentless bombardment of charged particles. The moon that looks so much like Earth today will become just another airless ice ball, a frozen corpse orbiting a dying planet. These interactions, these connections between Saturn and its moons, remind us that the Saturn system is not a collection of isolated objects. It is a complex, interconnected system where everything affects everything else. The moons shape the rings through gravitational interactions, creating gaps and waves in the ring material. The rings feed material into the magnetosphere. The magnetosphere strips atmospheres from moons. Saturn's gravity flexes and heats moons like Enceladus, creating habitable environments beneath their icy shells. It is a symphony of gravitational forces, magnetic fields, and chemical interactions playing out on a scale almost too vast to comprehend. And yet, for all its strangeness, for all its violence and chaos, Saturn has taught us profound lessons about our place in the universe. Before Cassini, before Voyager, we thought we understood planets. We thought we knew what moons were: dead rocks orbiting in the darkness. We thought life, if it existed anywhere beyond Earth, would be found on planets in the habitable zones of stars, places where liquid water could exist on the surface. Saturn shattered those assumptions. Enceladus showed us that you do not need a planet to have liquid water. You do not need to be in the habitable zone of a star. All you need is a source of heat. And tidal heating from a massive planet can provide that heat just as well as radiation from a sun. Suddenly, the number of potentially habitable places in our solar system, and by extension, in the universe, expanded enormously. Every large planet with icy moons became a candidate for harboring life. The moons of Jupiter, the moons of Uranus and Neptune, even the moons of distant dwarf planets in the Kuiper Belt, all of them might have subsurface oceans kept liquid by tidal heating. The universe became a much more interesting place. Titan showed us that organic chemistry, the chemistry of carbon-based molecules that forms the foundation of life on Earth, can occur in environments radically different from our own. Titan's atmosphere is filled with organic molecules, complex hydrocarbons created by ultraviolet light breaking apart methane and allowing the carbon atoms to recombine in countless different ways. The surface is covered in organic material. If we could somehow warm Titan, melt its water ice, and evaporate its methane lakes, we would be left with a world covered in organic compounds, the raw materials for life, waiting for the right conditions to begin the journey from chemistry to biology. These discoveries force us to reconsider what we mean by habitable and what we mean by life. We have always assumed that life requires liquid water, organic molecules, and a source of energy. Enceladus and Titan show us that these ingredients are far more common in the universe than we ever imagined. They exist in places we never thought to look, in conditions we assumed were too hostile for anything to survive. But Saturn has also taught us about violence, about the destructive power of gravity operating on cosmic scales. The rings, those beautiful structures, are a reminder that gravity does not create only beauty. It also destroys. It rips moons apart. It draws material inward, crushing it, pulverizing it, grinding it down into ever smaller fragments. The Great White Spot, erupting every 30 years, shows us that planetary atmospheres are not stable, peaceful systems. They are pressure cookers of energy, capable of releasing storms that would dwarf anything in human experience. The hexagon at Saturn's North Pole shows us that nature can create patterns that seem almost artificial, that the laws of physics can produce structures so regular, so geometric, that they challenge our intuitions about what natural processes can create. When we see straight lines and perfect shapes, we assume intelligence, design, purpose. But the hexagon is none of those things. It is simply the outcome of fluid dynamics operating under specific conditions. Rotating fluids, temperature gradients, Coriolis forces all combining to create a pattern that looks designed but is purely natural. It is a humbling reminder that the universe is full of phenomena we do not yet understand, patterns that emerge from the fundamental laws of physics in ways that still surprise us. And perhaps that is the most important lesson Saturn teaches us. For all our knowledge, for all our spacecraft and telescopes and computer models, we are still only beginning to understand this place. Every mission to Saturn has raised more questions than it answered. Every new image from Cassini revealed something unexpected. The universe is stranger than we imagine, and it is stranger than we can imagine. To paraphrase a famous quote, Saturn is proof of that strangeness. Consider the sounds. At the beginning of this journey, we mentioned the sound of Saturn screaming into the void. This is not a metaphor. Saturn emits radio waves, electromagnetic radiation in the radio frequency range, generated by interactions between the solar wind and Saturn's magnetosphere. When these radio waves are converted into audible sound waves, when we take the electromagnetic signal and map it onto frequencies, humans can hear the result as eerie, haunting, almost like a voice crying out in the darkness. It is the sound of a planet-sized electrical system, of charged particles spiraling along magnetic field lines, of energy cascading through the magnetosphere in ways we still do not fully understand. But to our ears, to our pattern-seeking minds, it sounds like a scream. It sounds like Saturn is trying to tell us something. What could it be saying? Perhaps it is a warning. Stay away. I am dangerous. I destroy moons and vaporize spacecraft and create storms that would tear your fragile bodies apart. Or perhaps it is an invitation. Come closer. Learn from me. Discover the secrets I hold. Find the life that might swim in my moon's hidden oceans. Or perhaps it is saying nothing at all, because it is not a voice, but merely physics. The inevitable outcome of a magnetic field interacting with plasma, no more meaningful than the wind howling through a canyon. But we cannot help but see meaning in patterns. We cannot help but project consciousness onto the universe, to to imagine that planets and storms and magnetic fields have intentions, personalities, desires. Saturn is not malevolent. It is not trying to destroy us. It simply is a collection of matter obeying the laws of physics, shaped by gravity and chemistry and thermodynamics into the form we observe. And yet, when we look at it, when we see the hexagon staring back at us like an eye, when we hear the radio emissions that sound like screams, we cannot help but feel that we are in the presence of something vast and ancient and utterly indifferent to our existence. That indifference might be the most terrifying thing of all. We are accustomed to thinking of ourselves as important, as central to the story of the universe. But Saturn reminds us that we are not. We are insignificant specks on a tiny planet orbiting an average star in an ordinary galaxy. Saturn was here billions of years before we existed, and it will be here billions of years after we are gone. It does not care about us. It does not notice us. We could launch 1,000 spacecraft at Saturn, or we could never visit it again, and it would make no difference to the planet itself. It would continue to spin, continue to storm, continue to slowly consume its rings and heat its moons and scream radio waves into space, utterly unchanged by our presence or absence. And yet, we care about Saturn. We send spacecraft there. We spend billions of dollars and decades of effort to study it. We risk the destruction of those spacecraft, as we did with Cassini, to learn its secrets. Why? What drives us to explore these alien worlds that will never notice our existence? Perhaps it is because in understanding Saturn, we understand ourselves. By studying how planets form, how atmospheres evolve, how magnetic fields are generated, we learn about the processes that shaped Earth, that made our world capable of supporting life. Saturn is a natural laboratory, a place where we can observe physics operating under conditions we can never replicate on Earth. By studying Saturn's atmosphere, we learn about fluid dynamics and thermodynamics on scales impossible to achieve in our laboratories. By studying its moons, we learn about the possibilities for life beyond Earth, about the environments where biology might arise. Or perhaps we explore because it is in our nature, because we are curious, because we look up at the night sky and see points of light and cannot help but wonder what they are, what secrets they hold, what stories they could tell if only we could read them. Saturn is a story, written in ice and gas and magnetic fields, and we are learning to read that story, one spacecraft mission at a time, one image at a time, one radio signal at a time. So when you look at Saturn, remember what you are seeing. You are not looking at a peaceful jewel floating serenely in space. You are looking at a violent, chaotic world, a planet that tears moons apart and generates storms that could swallow Earth whole. You are looking at a graveyard of shattered worlds, at rings made from the corpses of dead moons. You are looking at geometric nightmares carved into atmospheric winds, at mysteries we still cannot explain. You are looking at moons that might harbor life in their hidden oceans, at worlds of methane rain and plastic sand, at geysers shooting water hundreds of kilometers into space. You are looking at beauty, yes. Saturn is undeniably beautiful. But that beauty is dangerous. It is seductive. It draws us in, makes us forget the violence that created it, and sustains it. The rings are beautiful because a moon died. The geysers of Enceladus are beautiful because gravity is crushing that tiny moon with unstoppable force. The hexagon is beautiful because it represents atmospheric dynamics operating at scales and intensities that would destroy any human structure in seconds. Saturn is the most beautiful thing in our sky. But remember, always remember, that beauty can be deadly. Beauty can be a trap. Beauty can lure you into forgetting the terrible forces at work, the violence simmering beneath the surface, the indifference of nature to our existence and our aspirations. And perhaps that is the final lesson of Saturn. The universe does not care about us. It is not designed for our comfort or our survival. It is vast and ancient, and operating according to laws that existed long before we did and will continue long after we are gone. Saturn is a monument to that indifference, a golden giant crowned with the remains of murdered moons, spinning in the darkness, screaming radio waves into the void, beautiful and terrible, and eternal in its temporary glory. Look at it while you can. The rings are dying. One day, they will be gone, and Saturn will be diminished. stripped of the feature that made it unique. We are living in a brief window, a moment of cosmic time, when Saturn wears its crown. Appreciate that. Understand what you are seeing, and remember that you are gazing at the Lord of Chaos itself, a world that has shown us wonders and horrors in equal measure, a world that has expanded our understanding of what is possible in this universe, while simultaneously reminding us of how small and fragile we truly are. Saturn is not peaceful. Saturn is not gentle. Saturn is magnificent and terrifying, beautiful and deadly, a cosmic masterpiece painted in violence and adorned with the debris of its victims. That is the truth about the jewel of the solar system. That is the reality behind the beauty. And that is why Saturn will always be, to those who truly understand it, the scariest planet in our solar system.